Hey, you know how most buildings are all about keeping nature out? Well, I just found out something incredible. There are actually buildings around the world designed to do the total opposite. They've built entire ecosystems inside of them. Seriously, you gotta see this one. Today's video is on 15 buildings with entire ecosystems built inside them. Starting with number 15, the Amazon Spheres in Seattle. So these spheres are a trio of interconnected glass domes located at Amazon's headquarters in downtown Seattle. They were officially opened in 2018, and they were designed to serve as a workspace for the employees while also housing a curated indoor rainforest. The structure has over 40,000 individual plants from more than 50 countries. Each of these three glass domes ranges in height from 80 to 90 feet, and it spans an overall footprint of about 65,000 square feet. The glass panels are coated with a high-performance film to control heat gain and reduce any glare. Natural ventilation, misting systems, and LED lighting all help regulate temperature and humidity. Now, the plant life inside there includes epiphytes, ferns, bromeliads, and mature trees that were specifically chosen for their ability to survive in a controlled tropical climate. Many of these species are typically found in highland cloud forests, where temperature and moisture levels remain stable year-round. Now, one of the central features of the spheres is a 55-foot-tall living wall, which hosts thousands of plants growing vertically on a hydroponic frame. This wall serves as a visual and environmental function by increasing the interior humidity and contributing to the air quality. Walkways, suspended bridges, and quiet seating areas are woven throughout the vegetation, and that encourages movement and informal meetings among the employees. In addition to serving as a workspace, the facility is used for botanical research too, and experimentation with indoor environmental conditions. Sensors and control systems collect real-time data on temperature, soil moisture, light levels, and plant growth, which are used to inform both horticultural practices and future building projects. These spheres represent a significant investment in biophilic design. That's an architectural approach that incorporates natural elements into the built environment to support mental health, productivity, and ecological literacy. While the primary goal is to serve Amazon employees, of course, the project also acts as a demonstration of how large-scale buildings can integrate living systems without compromising on function. Number 14, the Eden Project in Cornwall, England. So the Eden Project, it's a large-scale complex that's located in a reclaimed clay pit in Cornwall in England, and it was opened to the public in 2001. It consists of 2 massive biomes and several outdoor gardens. Each biome is a self-contained ecosystem housing plant species from different global climates, and it operates as a public education center focused on sustainability and the relationship between humans and the environment. Now, the 2 main biomes are constructed from hexagonal and pentagonal ETFE panels supported by steel frames. The larger of the 2, known as the Rainforest Biome, is the world's largest indoor rainforest at 55 meters tall, 100 meters wide, and 200 meters long. It's got plants in there from tropical regions including Southeast Asia, West Africa, and South America. It maintains a humidity level of around 80 to 90% and temperatures between 18°C and 35°C. That's about 64 degrees Fahrenheit to 95 Fahrenheit, depending on the plant requirements and the time of year. The second biome, the Mediterranean biome, replicates the climates found in California, southern Europe, and parts of Australia. It contains olive trees, grapevines, and aromatic herbs like lavender and rosemary. The Mediterranean biome uses a separate climate control system to maintain lower humidity and more moderate temperatures throughout the year. But both biomes feature controlled irrigation systems, artificial rainfall, and monitoring equipment. Maintenance teams in there include horticulturalists, soil scientists, and environmental engineers who work together to sustain the ecosystems without allowing any single species to dominate. Now, the Eden Project also includes an outdoor biome that features plants adapted to the temperate climate of Cornwall, and that serves as a living laboratory for native and non-native species. It's used extensively for school field trips, research programs, and even environmental workshops. This project has received international recognition for its combination of ecological function and public engagement. It continues to expand its programming and research efforts, and they partner with universities and conservation groups worldwide. While it functions as a tourist attraction, its primary goal is to model how human-made environments can replicate and support natural systems for both educational and ecological benefit. Number 13, the Singapore Cloud Forest. The Cloud Forest is one of two large glass conservatories located within the Gardens by the Bay complex in Singapore. This place was opened in 2012, and the facility was designed to replicate the cool, moist environment found in tropical mountain regions between 1,000 and 3,000 meters in elevation. The structure stands about 58 meters tall. It's built from steel and glass panels and supported by an arched framework. Inside, the primary feature is a 35-meter man-made cloud mountain, a vertical structure covered in ferns, orchids, mosses, and bromeliads. This mountain is hollow and houses a series of ramps and elevators that allow visitors to ascend through multiple levels of displays, each with different moisture and light conditions. A fine mist is released periodically to simulate cool fog, and the entire climate control system is digitally monitored and powered in part by renewable energy. The collection of plants includes more than 1,000 species, selected for their relevance and adaptability to enclosed environments. Many of these plants are threatened in their natural habitats, and the Cloud Forest serves as a conservation showcase. In addition to these exhibits, the Cloud Forest includes educational installations on biodiversity loss, sustainable development, and climate change. A multimedia section known as the Crystal Mountain explains the structure and formation of stalactites and stalagmites, integrating geology with plant biology. And the top of the Cloud Mountain offers an amazing panoramic view of the conservatory and features displays focused on mountain ecology. It's open to the public and it receives over 1 million visitors annually. It functions as both an educational institution and a conservation facility. Its enclosed, climate-specific design allows species from distant and fragmented ecosystems to be studied in a controlled environment, providing data that supports broader conservation efforts in Southeast Asia. Number 12. The Montreal Biodome. The Montreal Biodome is a multi-ecosystem indoor facility located in the Olympic Park district of Montreal, Quebec. Originally built as a velodrome for the 1976 Summer Olympics, this building was converted into the Biodome in 1992, and it now houses 5 distinct ecosystems found in the Americas. These include the tropical rainforest, the Laurentian maple forest, Gulf of St. Lawrence, the Labrador coast, and subantarctic islands. It covers over 7,500 square meters, and it features separate climate-controlled zones that support both plant and animal life. And the zone maintains a temperature of about 28 degrees Celsius, that's 82 Fahrenheit, with 70 to 90% humidity. It's got species in there like sloths, capybaras, poison dart frogs, and over 120 plant varieties. The Laurentian maple forest simulates a temperate, deciduous environment found in eastern Canada, with seasonal changes built into the lighting and temperature systems to mimic the real world. The Gulf of St. Lawrence system features a large saltwater basin with over 2.5 million liters of water, and that's home to aquatic species like Atlantic salmon, sea stars, and puffins. The Labrador coast has subarctic tundra boreal forest environments with snow and ice during the winter months, and the subantarctic island zone replicates the environments of the islands near Antarctica, including artificial rock formations and chilled air systems. Penguins, especially the king variety, are among its primary residents. But in addition to live exhibits, the Biodome features interpretive centers and educational programming. The facilities here collaborate with universities and conservation groups on research involving habitat simulation, captive breeding, and animal behavior. The Montreal Biodome is fully open to the public, and it serves both recreational and scientific purposes. With an average of 800,000 visitors a year, it remains one of the most visited museum-type institutions in Canada. The ability to house multiple ecosystems here under one roof makes it a unique case study in biome simulation. Number 11. The California Academy of Sciences in San Francisco. Located in San Francisco's Golden Gate Park, the California Academy of Sciences is a multidisciplinary scientific institution that integrates an aquarium, planetarium, natural history museum, and a living rainforest under one roof. A central feature here is the 4-story Osher Rainforest Dome, an enclosed climate-controlled structure housing a vertical slice of tropical rainforest from floor to canopy. The dome stands 27 meters or 90 feet wide and about 27 meters high. It's enclosed by a transparent acrylic structure that allows sunlight to penetrate the system. The interior is organized into 4 distinct habitat zones: the Amazon Basin, Southeast Asian forest, African rainforest, and a cloud forest. Each zone contains region-specific plants and animal species, like the Amazon section, for example, has bromeliads, orchids, and of course poison dart frogs, and visitors move through the biome along a spiraling ramp that ascends through the canopy layer. The Academy's living roof, which covers over 87,000 square feet, is planted with native Californian species and features undulating mounds that correspond to interior exhibit spaces. The roof's home to over 1.7 million native plants, and it's monitored for pollinator activity and seasonal variation. The dome also supports research initiatives related to insect behavior, amphibian health, and plant-pollinator interactions. This rainforest dome contributes to the Academy's mission by offering visitors a close-up view of tropical ecosystems in operation. It's a public exhibit and a functional research space, allowing real-time observation of ecological process. The Academy partners with institutions worldwide on conservation and data sharing programs that's focused on climate change and species preservation. Number 10. The Royal Greenhouses in Belgium. So the Royal Greenhouses of Laeken are a complex of interconnected glass and iron greenhouses located within the park surrounding the Royal Castle of Laeken, the residence of the Belgian royal family. Built between 1874 and 95 during the reign of King Leopold II, these greenhouses combine history, architectural design, and living plant ecosystems, many of which were sourced from former Belgian colonial territories. The complex covers about 2.5 hectares and it contains several major structures, including the Winter Garden, Congo Greenhouse, and the Orangery. The largest structure, the Winter Garden, has a dome that stands over 25 meters high and spans over 57 meters in diameter. Now, the royal greenhouses themselves house a huge botanical collection, including azaleas and palm trees, and many of the trees were planted in the 19th century and are now over 100 years old. A highlight of the Congo greenhouse, which was constructed to showcase plant species from Central Africa, includes banana plants, coffee trees, and rubber trees, and the orangery contains citrus trees and subtropical species that are rotated outdoors during the summer months. The Royal Horticultural Service is responsible for the maintenance of the gardens and the plant collections. Many of the plants are grown from original specimens or sourced through botanical exchange programs. Access to the greenhouses is limited. They're open to the public only a few weeks each spring, attracting tens of thousands of people who walk along designated paths. Outside of that window, though, the site is reserved for research, royal use, and maintenance. The collections here reflect Belgium's historical ties to tropical regions and serves as a living representation of biodiversity from across the world. The buildings themselves are considered an architectural precursor to modern glasshouse design, influencing the development of botanical conservatories in Europe and beyond. Number 9. The Green Planet, Dubai. The Green Planet is an indoor tropical rainforest biome located in the City Walk district of Dubai. It was opened to the public in 2016, and it's an educational and recreational facility that's focused on rainforest ecosystems. It's built in one of the world's most arid environments, and it recreates the conditions of a South American rainforest inside of a 4-story biodome. Yeah, it's artificial, but its highly controlled environment has over 3,000 plant and animal species, representing a major technical achievement in indoor ecosystem simulation. The core design centers around a cylindrical glass structure with a height of about 30 meters. Within there is a central man-made tree that stands about 25 meters tall and serves as a symbolic and functional core of the ecosystem. Around this tree are various plant zones and animal habitats organized across vertical levels, and environmental conditions inside there are controlled to mirror tropical rainforest parameters, temps between 25 Celsius and 28 Celsius, and humidity levels about 70 to 80%. The biome features a variety of plant life, including epiphytes, ferns, palms, bromeliads, and flowering trees found in equatorial regions. Many species here rely on the humid air for moisture, and their placement is structured to mimic canopy, understory, and forest floor arrangements found in actual rainforests. Now, the artificial tree in here is not merely decorative. It does function as a vertical anchor for air circulation, water distribution, and temp regulation systems. Embedded within the tree are concealed irrigation lines, lighting elements, and airflow ducts. A closed-loop water system collects condensation and excess misting waters, filters it using UV and carbon systems, then reintroduces it into the environment. And the Green Planet doubles as an educational center. Guided tours, school programs, and interactive exhibits help educate the public about deforestation and rainforest ecology. Information panels are placed throughout the building, and digital touchscreens offer details on species and conditions. Dubai's hot desert climate has some logistical challenges in maintaining a stable indoor rainforest. The facility offsets some of its environmental impact, though, through renewable energy purchases and water recycling, though it still relies heavily on municipal infrastructure. Unlike botanical gardens that house plant species in segmented greenhouses, the Green Planet integrates plants and animals in a layered, interactive space. This holistic layout enhances the educational value here by demonstrating interdependence. But the whole facility remains one of the only living rainforest systems in the Middle East. Its continued operation depends on high-precision engineering and careful biological oversight. While it obviously can't replace the role of real rainforests in the global ecology, it provides an accessible model for just understanding how those systems function and what is lost when those are destroyed. Number 8. The biomes at Biosphere 2 in Arizona. Biosphere 2, it was a large-scale enclosed research facility located in Oracle, Arizona, about 50 kilometers north of Tucson. It was originally constructed between 1987 and 1991 and was intended as an experimental closed ecological system to explore the viability of self-contained habitats. Now, while the original human-sealed missions ended in the 1990s, the facility was repurposed as a science center and now operates as a University of Arizona-run laboratory. It covers more than 3.1 acres and includes 5 interconnected biomes: a tropical rainforest, a savanna, a fog desert, a mangrove wetland, and an ocean. Each biome was constructed with specific soil types, water chemistry, and plant species. Now, the rainforest biome contains over 90 species of tropical plants from Central and South America, Southeast Asia, and even Africa. These include fast-growing hardwoods, epiphytes, and understory shrubs. The savanna biome simulates grassland and scrub conditions found in parts of Africa and North America. It includes drought-tolerant grasses, acacia trees, and semi-arid shrubs. The fog desert biome has coastal deserts like those in Baja California and parts of Namibia, characterized by cooler temperatures and lower rainfall. This zone features succulents, cacti, and fog-fed vegetation. The mangrove biome is a tidal wetland system that mimics the brackish coastal environment. It has mangrove trees, salt-tolerant grasses, and marine invertebrates. Water salinity here is carefully regulated, and tidal movements are simulated using pumps to recreate the ebb and flow of coastal wetlands. And the ocean biome has a 1 million liter tank designed to simulate a coral reef environment. Though initial efforts to maintain a coral ecosystem did face technical difficulties due to water chemistry and light penetration, ongoing projects have refocused on microbial dynamics and nutrient flow. Today, Biosphere 2 functions primarily as a scientific facility. It has research programs from the University of Arizona, NASA, and international institutions. The site also supports educational programs for university students and the public, and it offers tours, lectures, and live-streamed experiments. The Biosphere 2 remains one of the largest and most diverse ecological simulation buildings in the world. By housing entire ecosystems in engineered conditions, it offers researchers a rare opportunity to manipulate and observe variables impossible to isolate in natural settings. This ability makes it an invaluable tool in the ongoing effort to understand the Earth's complex systems. Moving on to number 7, the Museum of Science in Italy. The Museo delle Scienze, or MUSE, is a science museum located in Trento, Italy, which incorporates a fully integrated indoor greenhouse that replicates a tropical rainforest. Opened in 2013, MUSE was designed by architect Renzo Piano, and it covers over 19,000 square meters. Now, while the museum includes a broad range of scientific exhibits spanning geology, biology, and technology, it's the top-floor tropical rainforest greenhouse that exemplifies a large-scale, purpose-built ecosystem. The exhibit's structural design allows natural light to flood into the enclosure, filtered through high-performance glass that reduces any UV or infrared radiation to prevent overheating. Heat generated during the day actually helps warm other parts of the building, while a chilled water system and misting apparatus maintain tropical conditions. Temperatures are maintained around 28 degrees Celsius or 82 Fahrenheit during the day and slightly cooler at night, and humidity ranges between 70 to 90%, with periodic misting events happening throughout the day. The vegetation inside the greenhouse includes trees, vines, shrubs, and ground flora native to the eastern arc forests of Africa. Epiphytes like orchids and bromeliads grow on support structures designed to initiate rainforest canopies. One of the core objectives of this greenhouse is storytelling. Interpretive displays accompany the plantings, explaining topics like nutrient cycling, forest stratification, and the role of rainforests in the global carbon and water cycle. Animal life is present but limited to select invertebrates and amphibians, housed in contained microhabitats. Larger animals are represented digitally through interactive exhibits and video footage from the museum's field research in Africa. Visitors will ascend through a natural history and climate change exhibit before reaching the rainforest, a deliberate progression that mirrors evolutionary and ecological complexity. Educational programs here include workshops, guided tours, and curriculum-based modules for schools. They also offer training for educators in environmental literacy and sustainability science. Muse's rainforest is not the largest enclosed system in the world, but it is one of the most integrative, linking architectural design, science, public education, and biodiversity conservation in a cohesive experience. The facility maintains partnerships with institutions in Africa which promote reciprocal research and capacity building in tropical ecology. It shows that even within the constraints of a mid-sized European city, it is possible to build, maintain, and use a living tropical forest for both learning and long-term research. Number 6. Botanical Gardens of Kurichiba, Brazil. The Botanical Gardens of Kurichiba is one of the most iconic public botanical facilities in Brazil, and it includes a landmark glass house that has a fully functional Atlantic forest ecosystem in it. Opened in 1991 and modeled on 19th century European greenhouses, this facility sits within a larger 278,000 square meter park. Its central glass house, made of metal and glass, serves as both a symbolic and functional role, enclosing a microhabitat reflective of Brazil's endangered coastal rainforest. It stands about 20 meters tall and covers over 450 square meters, and it's designed in the style of London's Crystal Palace, with the central dome flanked by two smaller wings. The Atlantic forest is one of the most threatened ecosystems in the world, originally spanning Brazil's coastal regions. It now exists in fragmented patches due to urbanization and agriculture. This greenhouse in Kurichiba simulates the conditions of this biome using curated plant collections, soil mixtures, and controlled rainfall and humidity. The plant species here includes bromeliads, philodendrons, ferns, and orchids, plus hardwood trees like the endangered pau Brazil. Each plant group is selected based on ecology compatibility, forming a small-scale analog of actual forest canopy. Outside the glass house, additional gardens represent other Brazilian biomes: cerrado, campo, limpo, and aquatic plant environments. These open-air exhibits are supplemented by an adjacent research center and a small experimental station where propagation, restoration, and conservation projects are undertaken. Educational outreach here is a major component of their mission. The greenhouse is integrated into school programs, offering activities on climate adaptation, plant morphology, and species identification. Though not the largest or most technologically advanced indoor ecosystem in the world, this one has earned recognition for its role in regional conservation. By focusing on native and endangered systems, the garden offers a rare local context for environmental education in urban settings. In recent years, research has become a focus. The facility is testing how shifting rainfall patterns and temperature changes affect plant health and reproduction. These findings are being integrated into broader studies of forest resilience in urban greening and subtropical zones. It remains a living exhibit, it's a research site, and a cultural symbol of Kurichiba's broader environmental planning legacy. Number 5. The Flower Dome in Singapore. The Flower Dome is one of two massive climate-controlled conservatories within Singapore's Gardens by the Bay. Designed as a cooled glass house rather than a traditional tropical biome, this one replicates the semi-arid subtropical climates found in regions like the Mediterranean Basin, parts of South Africa, Australia, California, and Chile. It's more than just a botanical attraction, though. The Flower Dome functions as a living laboratory and a fully operational indoor system designed to exist within Singapore's equatorial humidity. It was officially opened to the public in 2012 alongside its counterpart, the Cloud Forest, which we talked about. Together, these structures represent the centerpiece in Singapore's urban greening strategy. Structurally, the dome consists of over 3,300 specially shaped glass panels supported by 42 arches with no internal columns. These glass panels are high performance and selectively coated to filter solar radiation. To cool the interior, the dome uses a system known as cooled conservatory technology. Cold water is circulated beneath the floor slabs and benches, enabling radiant cooling. This method is more efficient than traditional air conditioning because it cools occupants and plants directly through conduction rather than by lowering the air temperature across the entire dome. The dome is organized into thematic zones, each representing a different Mediterranean or semi-arid region. These zones include the baobabs and bottle trees area, which has African succulents and drought-tolerant species, the South African garden, which has proteas, aloes, and cycads, the Australian garden with eucalyptus, acacia, and banksia species, the California garden, which has redwoods, coastal shrubs, and chaparral species, and the Mediterranean garden showing olive trees, grapevines, lavender, rosemary, and cypress trees, plus the succulent garden, which has desert-adapted plants like agaves and cacti. Now, operationally, the dome is monitored by a building management system that tracks over 60,000 data points in real time. These include temperature, humidity, light intensity, carbon dioxide levels, and equipment performance. The system's configured to alert horticultural staff and engineers of any deviations outside the acceptable range. Since its opening, the Flower Dome has received international recognition for its scale, precision, engineering, and public engagement. The dome's success has led to renewed interest in large-scale conservatories as platforms not just for display, but also for climate modeling, education, and species banking. As environmental pressures increase globally, especially in water-stressed and desertifying regions, the Flower Dome shows that ecosystems can be preserved, studied, and appreciated in constructed environments. Its success hinges on interdisciplinary collaboration, continual monitoring, and the willingness to integrate botanical knowledge with engineering. In doing so, it not only brings distant ecosystems into the public reach, but it also helps shape the future, thinking about how biodiversity can be protected and studied in an increasingly urban world. Number 4. The Rainforest Pyramid in Galveston, Texas. The Rainforest Pyramid at Moody Gardens. It's one of the most extensive indoor rainforest biomes in the U.S. In Galveston, Texas, this large glass structure is part of the Moody Gardens complex. It also includes a public aquarium, an IMAX theater, and educational exhibits. It was opened in 1993 and substantially renovated in 2011. The pyramid was built with the purpose of providing a complete sensory and educational experience. Now, its most distinguishing feature is the integration of animals and plants into a cohesive environment that mimics the complexity of a living rainforest. Covering over 10 stories in height and 29,000 square feet of floor space, this pyramid includes canopy-level walkways, cave systems, and humidity-regulated pathways. Vegetation inside there has over 1,000 plant species, representing rainforest biomes from around the world. Special attention is given to vertical forest stratification, with the structure divided into canopy, understory, and forest floor levels. Plants are grown in engineered soil systems that allow for nutrient recycling, root expansion, and efficient water drainage. Drip irrigation does complement the natural rain simulation here, ensuring that plants get specific moisture levels. The pyramid's canopy walkway is a central feature, allowing visitors to travel in the treetops on elevated paths and observe animals and plants from a rarely experienced perspective. This elevation provides a direct exposure to canopy species like fruit bats, tree frogs, and orchids. Below, winding trails pass through the forest floor environments with aquatic features, root systems, and darkened areas that replicate the dim light levels of actual rainforests. Behind the scenes, Moody Gardens has a support complex with veterinary facilities, quarantine zones, nurseries, and even climate control hubs. The veterinary team conducts routine health exams, and each animal's behavior and diet are logged daily. Moody Gardens itself is part of a broader system in Galveston. The complex contributes to environmental awareness in a region that is vulnerable to hurricanes, coastal erosion, and rising sea levels. By housing tropical and marine systems indoor, the Rainforest Pyramid can provide year-round environmental education. It also serves as a refuge for species affected by weather events. During Hurricane Harvey in 2017, the pyramid remained intact and operational, protecting its animals and plants through a prolonged regional flooding. It offers a tangible experience of ecosystem function and fragility. It's condensed into a walkable, observable space that draws over 300,000 people annually. Few indoor facilities offer such breadth in both flora and fauna, and even fewer manage to simulate ecosystem-level interactions. The Rainforest Pyramid at Moody Gardens is one of the most comprehensive indoor rainforests ever built. Number 3. The Palm House in London. The Palm House at the Royal Botanic Gardens, Kew, is one of the world's most historically significant glass houses and one of the earliest architectural structures specifically designed to house a simulated ecosystem. Located in Kew, West London, the Palm House was constructed between 1844 and 1848, and it still remains operational. The building's about 110 meters long and 30 meters wide, and it stands about 19 meters tall at its central dome. It was the first large-scale structure built using wrought iron in combination with glass, predating similar methods used in railway stations. Structurally, the Palm House features a central nave with two lateral wings, a network of curving iron ribs, and over 16,000 panes of glass. Originally, the interior climate was maintained using coal-fired boilers and a network of hot water pipes that ran beneath the planting beds. To simulate the high humidity, consistent temperature, and diffused light typical of lowland tropical rainforests was used. The interior temperatures were regulated between 20 degrees and 28 degrees Celsius, that's about 68 to 82 degrees Fahrenheit, with relative humidity at about 80 to 90%. The biome inside the Palm House includes an extensive curated selection. Examples from the Americas, Africa, Asia, and the Pacific, and the plants are arranged into ecological zones that reflect their natural environments. The collection includes several economically and ecologically important species like cocoa, native to Central and South America and the source of chocolate; banana, a staple crop cultivated globally; oil palm, controversial in the context of deforestation but maintained for educational purposes; sugarcane, originally from Southeast Asia, representing one of the oldest cultivated crops; and coffee, illustrating the evolution of tropical understory plants. The interior of the Palm House is arranged vertically as well as horizontally. A central staircase leads to an overhead gallery that runs along the building's perimeter, and this vertical stratification gives insight into the different layers of a rainforest: the emergent layer, the canopy, the understory, and the forest floor. Watering is performed using both automated and manual methods, and misting systems create ambient humidity, especially during colder winter months. Drainage is managed by a subsoil network that allows for both excess water removal and microbial activity. In addition to on-site education, the Palm House contributes data to global research networks. Kew collaborates with institutions involved in climate change modeling, particularly concerning how tropical plant species responds to shift in temperature, CO2 levels, and light. And although the Palm House doesn't house animals in the same way as some modern biomes, it does support insect populations that contribute to the realism. Pollinators like bees and hoverflies are sometimes introduced in controlled numbers, and naturally occurring insect life is of course managed rather than eliminated. From a cultural perspective, the Palm House has become an enduring symbol of Victorian science and global plant exchange that accompanied European exploration and colonial expansion. Its collections include species obtained through the 19th century expeditions, many of which entered botanical collections before conservatory ethics were adopted. As such, the Palm House also functions as a living archive of historical plant collecting. In its current form, the Palm House bridges the 19th century with 21st century botanical science. It serves as a living example of how built environments can support ecology complexity. Whether it's viewed as a marvel of engineering, a hub of plant research, or an educational tool, the Palm House exemplifies what is possible when architecture and ecology are integrated, and it continues to inspire generations of scientists, conservationists, and the public. Number 2. The Desert Dome, Omaha, Nebraska. The Desert Dome at Omaha's Henry Doorly Zoo is one of the most ambitious and advanced indoor biomes ever constructed. Opened in 2002 and visible for miles around due to its size, it remains the largest indoor desert in the world. Standing 42 meters high and spanning a base diameter of about 56.6 meters, the dome encloses over 84,000 square feet of climate-controlled space. Now, its purpose is to replicate the environmental conditions, plants, and animals of 3 distinct desert regions from across the world: the Namib Desert of southern Africa, the Red Center of Australia, and the Sonoran Desert of the southwestern US and northern Mexico. The Henry Doorly Zoo, recognized internationally for its leadership in habitat replication and species conservation, conceived the Desert Dome as a way to showcase biodiversity in arid climates. The dome maintains a daily temperature cycle that peaks at around 38 degrees Celsius, that's 100 Fahrenheit, during simulated midday conditions, and it drops to around 21 degrees Celsius or 70 Fahrenheit during the cooler night cycle, and humidity levels are kept between 10 and 20%. In the Namib Desert section of the dome, plants and animals here are arranged to illustrate life in one of the world's oldest and most arid environments. The Namib actually receives less than 10 millimeters of rain annually in some areas, and the plants there have adapted to collect moisture from fog. Plant species here include the extremely long-lived Welwitschia mirabilis, native aloes, and Euphorbius. The vegetation is spaced widely apart to reflect the competitive root zones and slow growth rates. Meerkats and foxes are given artificial burrows and raised rock formations that provide lookout points and shelter. The Sonoran Desert recreates North American deserts that receive slightly more annual precipitation, often delivered during short but intense summer monsoons. Accordingly, the vegetation here is more dense, and the dome's irrigation system for this area is programmed to deliver higher water volumes on a periodic basis. The soil is coarse and interspersed with stones, allowing for the drainage needed to prevent any root rot in cacti. Among the animals here in this section are desert tortoises, Gila monsters, burrowing owls, roadrunners, and a variety of lizards and snakes. In the Australian Red Centre portion of the biome, this dome displays a section of plants and animals that are specifically adapted to the soil and sporadic rainfall of the outback. Vegetation includes spinifex grasses, desert oaks, wattles, and eucalyptus. And because several Australian desert species have unique lighting and UV requirements, this section is equipped with specialized full-spectrum lighting. From an energy standpoint, maintaining a warm, dry climate inside a humid Midwestern environment poses some challenges. The dome uses passive solar heating during the day, with its glass panels and structural geometry optimized to maximize radiant warmth while minimizing heat loss. And it also plays a central role in the zoo's public education and outreach programs. Topics include adaptations to drought, thermoregulation, desert food webs, soil microbiology, and human impact on dryland environments. After more than 2 decades of continuous operation, the Desert Dome remains a benchmark for biome simulation and public engagement in arid land conservation. Unlike tropical greenhouses, which are common in botanical gardens, the Desert Dome addresses a biome type that receives less attention but holds immense ecological significance. As global desertification accelerates, understanding desert ecosystems becomes more urgent, and this building, with its self-contained, real-time model of multiple deserts under one roof, is a vital educational and scientific resource. Number 1. The Ocean Pavilion in Monaco. The Ocean Pavilion is one of the oldest and most scientifically respected marine institutions in the world. Founded in 1910 by Prince Albert I of Monaco, the museum was envisioned as both a center for marine research and a public exhibition space. Over the past century, the institution has evolved from a display of oceanographic curiosities into a fully integrated marine biome. Now, the building itself sits on the edge of a cliff above the Mediterranean, built directly into the limestone rock face of Monaco. The structure covers about 6,000 square meters and contains over 100 tanks and aquatic systems that replicate the conditions of real-world ocean environments. One of their most ambitious exhibits is the Coral Reef Tank, which simulates a shallow reef from the Indo-Pacific region. The tank contains both live coral colonies and fish species that would naturally coexist in the world. Live rock, harvested sustainably or grown in aquaculture facilities, is used to anchor the coral. Another key biome is the temperate lagoon system, modeled after the Mediterranean coastal wetlands and seagrass beds. This exhibit features a native seagrass that forms critical nurseries for fish and invertebrates. This tank uses natural sunlight supplemented with broad-spectrum LEDs, and the salinity is kept close to 37 parts per thousand, typical of the Mediterranean. Among the more unique exhibits is the Deep Sea Simulation Zone, which recreates the low-light, high-pressure environments of ocean depths. While it's not possible to replicate the actual deep-sea pressures inside a public exhibit, the pavilion uses specialized acrylic tanks and high-efficiency chillers to create a stable, dark, low-temperature environment. A separate section provides augmented reality simulations of hydrothermal vent ecosystems based on data and footage collected by submersibles, and these displays show tube worms, giant clams, and sulfide-emitting chimneys. Behind the scenes, the Ocean Pavilion maintains a quarantine facility for new arrivals. All animals brought into the system are observed for health and behavior in isolated tanks before any introduction into their intended biome. This process can take anywhere from a few days to several weeks, depending on the species and their origins. Unlike many public aquariums, this one was not retrofitted into a new building or modern structure. It was integrated into a historic edifice over a century old, which presented significant challenges. Floors had to be reinforced to support the heavy water tanks, and vibration dampening systems were installed to protect the building's foundations. The role of the pavilion extends beyond Monaco. It is a hub for global marine science outreach. Events like Monaco Ocean Week are hosted at the museum, drawing representatives from international NGOs and marine research institutions. And from a visitor's perspective, it offers a rare chance to witness the complexity of marine ecosystems in a walkable indoor space. As the health of our oceans becomes even more urgent, facilities like this one often serve as both sanctuaries for marine species and platforms for communicating the importance of preserving life beneath the surface.